sorry that we're starting a little bit late. So we had some technical difficulties. So if you haven't already, use this form to sign in so we can kind of like see how many people attended and things of that nature. And if you have not joined the Discord, use that QR code to join the Discord. So the point of that Discord is to just have a global place for people who are interested in the competition and the workshops, so that if they have questions, they can just ask it there. So maybe someone in another team, or like, someone was having that issue as well. So feel free to join that Discord. And by raise of hand, who has already seen any presentation about AI Racer already? Raise your hand if you have. Raise your hand if you have not seen, this is like your first time kind of like talking, or like seeing me, or like, like seeing about this presentation. Okay. All right. So I'll go through it quickly. So AI Racer, it is a student initiative to create and host a small scale autonomous racing competition here at UCF. It will be during the first week of April. So for the competition, this is pretty much what the vehicles will look like. If you kind of like, go through everything, we will try to provide you with the hardware and all of the necessary knowledge for it and all of that. And this is like the first workshop. This workshop is about ROS, Intro to ROS, which we pretty much use for everything in here. So this is kind of like this video is kind of like the competition. The competition is this one at least. It happened last year in May. We participated in so we basically trying to hardware and software and all of that. So for the competition itself, we're kind of like expecting at least one team from each major engineering club here at UCF. However, you don't have to be part of a club to participate. You can form your own team with, you can mix people up and all that. As long as you're able to compete, then, you can join the competition. So we will try to have all of the workshops to get you ready for the competition. And we will provide you with some hardware as well. But feel free to, bring your own stuff, modify things as you need. So the competition we'll try to host it twice a year. One in the fall, one in the spring. And we'll have 2 tracks for the competition. One will be simulation only, and one will be the physical vehicle competition. And that will also prepare like people for other external competitions, such as the Rover Racer or F110 that we sometimes participate. So why should you, want to like join the competition or do the workshops? Well, it's pretty fun, I would say, to kind of like work on these things. It's a pretty cool project. And as you know, every machine that moves will eventually become autonomous. So having skills in that area will put you, will give you an advantage in your career, especially if that's what you're actually interested in. And this is pretty much a rough draft of what the workshops will be like. So we'll have workshops in 3 categories: software, electrical, and mechanical. For the software side, we'll do Linux, ROS 2, kind of like this one, pretty much this one. We'll do sensor integration, mapping and localization, SLAM. We will do perception, planning, and control. And for the electrical side of things, we will do power system fundamentals, all of that. And for the mechanical, chassis selection and frame design. So the whole idea is that for the electrical side of things, we will try to make sure that you can create a power distribution board, which is pretty much this that's attached to the vehicle. The goal of the power distribution board is to get power from the battery and distribute it across everything on the vehicle, from the computing unit to the sensors and all of that. And for the mechanical side of things, it will be about, picking the right chassis and constructing a frame to house everything else. So, this is pretty much what I have here. I mean, it's a bit, it's a tad different, but it's pretty much the same thing. And, it starts with the chassis of the vehicle. You have the motor, the steering motor, the battery, wheels, and you will add your sensors and computing unit to it. For the sensors, you have 2D LiDARs, you have cameras, you have a ESC vest controller. The vest controller is to help you control the actual servo motor and also the actual motor for the vehicle. It makes it easier to interface those. And of course, you have Wi-Fi module to help you SSH into the computer as you're driving and all of that. And then you have the main computing unit for the vehicle. And on the software side of things, you have 3 groups: perception, planning, and control. So with perception, it starts with getting information about the environment from LiDAR cameras and all that. And then with that information, it goes through the planning phase. It's, what do you do with that information? What do you plan on doing? How do you actually race? And then control is how you actually do the action and all that. Send the commands. So that platform allows you to be ready for industry and also, be ready for research if that's what you're interested in and all that. So some quick questions and answers is, do you need to know how to program? Knowing how to use Python is a plus. I mean, you could learn on the way, but if you do already know how to use Python, that's pretty much it. And what should your background be in? It can be any major, as long as you're interested in the project itself, the competition, the workshops, you're free to tag along. And what we will provide is that we will try to provide the hardware and the knowledge and skills necessary to participate. Let me see. So yeah, so that's pretty much like a quick intro to what we are doing. And if you just came in, this is the sign-in form. Make sure you sign in. And for now, do you guys have any questions so far? Especially if it's your first time here. Yeah. So for the physical team itself, 3 to 4 is a good amount, I would say, but it doesn't have to be, it can be any number from 1 to whatever, as long as you guys can do the things that are required for it. Yep.
Are we like racing together, or are we racing in schools?
For the internal competition, we'll be racing each other. So the one in April, which is internal, will be kind of like racing each other. Any other questions? All right, so just so I can kind of like have a understanding of like who are here right now. So currently, I do know it's a mix of RSOs and like a mix of grade levels and all that. Raise your hand if you're a freshman. Okay, that's pretty good. Sophomore? Okay. Junior? Okay. Senior? Okay. Grad student? I'm a grad student, so yeah. All right, that's pretty good. Let's see, major-wise, raise your hand if you're computer science. Okay, Computer engineering. Okay. Electrical engineering. Okay. Mechanical. Ooh, nice. Industrial. Industrial engineering. Okay. Civil. What else? Am I missing anything? Aerospace. Okay. Any other engineering that I did not mention? What about non-engineering major? Okay. That's pretty good. So now let's see. So which RSO are you like most affiliated with? IEEE. If you're from IEEE, raise your hand. Okay. ACM. Okay. NESB. Okay. SHEP. Am I missing any RSO right now? Which one? Oh. Okay. Yeah, that's pretty good. So, did anyone came up with a question as I was talking? I don't know if I can answer any questions. Go ahead.
What are you doing in these workshops? Are you doing like electrical stuff? Are you doing most of the programming stuff? How does these workshops work?
So, for the workshops, depending on which workshop it is, which series of workshop it is, you will be learning what you pretty much need to build this and compete. So for the software series, this one is a workshop on the software series because you're learning about ROS. All of it's software. Everyone is encouraged to participate because you kind of like need to know how to use ROS anyway. So you.
So for the follow-up, for like power board system, we're designing a electrical circuit, so like PCB, right?
Yeah, we'll try to do that.
PCB or?
So that's a good question. For the electrical series, we will try to like teach you how to do it. However, if you want to print it, you can do it yourself. But we will provide you with an already built-in power supply. It's just that we will teach you how to do it in case you want to print it yourself, and in case if you're putting this project in your resume, and you're saying that this is what I did for this project, and they ask you a question about the PCB, then you can actually answer the question. So
for building part, are they using like easy EDA, like designing the PCB itself, like making all the connections, or how does the learning work?
well, for that, I'm still trying to figure out how I will do that because I will definitely need more help with the electrical side of things, and I don't know how time consuming it would be and all that. So it's still in progress, but as I get more information about it, I'll kind of like let you guys know, and you can kind of like move forward on that. Yeah.
What would the timeline of this be? Like weekly? What is the competition itself?
So the competition is first week of April. Haven't decided on the date yet. It'll probably be the first Friday, because that's usually when I'm the most free. So it will probably be the first Friday of April, and from now on, we will have at least one workshop per week, and one on Friday for sure at around this time. However, we will have more workshops, like multiple ones in 1 week and all that, but the date and time hasn't been decided yet. So, yeah. Any other questions? Yep.
What materials
Yes. So, when it comes to the hardware that will be provided, we currently have some sponsorship and with some research lab and also some external company. We have like a budget, to like buy material for the competition, and we will some lab will let us borrow their components. So we will try to give you as much as possible. You know, one team can even get all of the components for a vehicle. However, because our funding is very limited, we'll try to be more. It will depend. It will depend on like how many teams we will have, and we'll try to like have it kind of like more equal distribution of hardware, basically. Yeah, and of course, if you have a team and like you can support your team, or your RSO can support your team fully, please do so. You're actually helping us by doing so. So yeah, just keep that in mind.
So when you mentioned simulations, are you looking the remote query testing and the simulation, like if we are coding an AI model and stuff? And for the simulation, are you using any NVIDIA simulation or?
Now it will be just a simple simulation on ROS. It's not even Gazebo. It's just something to quickly test your algorithm. It's a 2D simulation built using Python. It leverages the gymnasium interface a little bit if you want to do reinforcement learning methods. But you'll see it next workshop. I mean, I could show it to you this workshop, but yeah, you will go through how to install it next workshop. And the point of that simulation is to quickly test your algorithm. And since the simulation is also based on ROS, the same way you test it on the simulation, you can just literally just put the same thing on the machine, and it will potentially work. Because obviously, when it comes to like simulation and stuff, things might work on the simulation and don't work in real life. So yeah, keep that in mind. Any other questions? Mm-hmm. So for the teams, you are free to form it yourself. However, if you are in need, if you need help with forming one, we can try to like put you in one. But if you can form it yourself, that would be like great. So, yep.
How many people, like, what's the max team?
No limit. I mean, you could. But like, just keep in mind that the more people you have in a team, the less effective it is. Because to be honest, I feel like as a group grows, the collective IQ drops. That's what I noticed. If the bigger the team, the more stupid. I don't know. But yeah, so just make sure you have like a good amount, something that the team can actually manage and people can actually contribute. So yeah. Yep. Good question. I don't know. The reason I'm saying I don't know is because we're still trying to get more sponsors to like help us with things such as prize money, or like, well, maybe not say money, prize, and sponsor individual teams and give us hardware. As of right now, you just have fun, man. That's all I can tell you. But we'll try to get something. It's just I don't know what it is yet. Any other questions? Yep.
I came in pretty late, so like, are the materials provided, or are we good to get our own? Or
so we will try to provide some material, at least as much as possible. It will all depend on how many teams are signing up for it. So for the teams themselves, we won't really have an official registration yet. We want to gauge how many people are actually interested, and then later in the next few weeks, I guess, we'll have like a form to officially register the teams, and then that's when we will try to figure out what can we provide you guys and what you might have to purchase yourself. And of course, there is a simulation phase in the competition. That one, anyone can participate. There's no, you don't need to buy anything for it. I mean, it's less cool, but it's there. Any other questions? Just so I can get an idea, how many people know for sure that they will be participating in the competition? Raise your hand if you know for sure. Okay. Raise your hand if you low-key have a team. Oh, okay. Raise your hand if you can support your team fully. Hey, big money. Okay. All right, that's good to know. So,
How does this, the whole
if you were to support yourself entirely, so. No, he's actually not lying. I'm not gonna lie. But basically, for this build itself, this is a industry level or research grade build, as in it's very rigid in a way. It won't break easily. Well, I would hope not. But yeah, for this one, if you were to build exactly this one, it will cost you about $3,800. So this LiDAR itself, the orange things, cost $1,500. Huh? Timu? Hey, that's what I'm saying. So this is if you want to go big, but obviously for your team, you can get whatever works for you, man, whatever works for your pocket. So, and yeah. And you can go on eBay. A few days ago, I was looking, I saw a guy selling 12 of these, 500 each. I was a bit skeptical, but I don't know. I might, because, hey, we'll see.
Even with a scalper, so I'm gonna go on Facebook Marketplace.
Facebook Marketplace? I don't know, man. I mean, 500 is already a steal. That's why I'm very skeptical,
That steal would be free, though.
Any other questions? Yep.
How sophisticated does the final product have to be? Are you expecting for the products to be more beginner or more advanced like that?
So the build itself or the algorithm? So I literally have zero expectation for right now because I don't really know how to what levels most people are in. But just so you can kind of have an idea of what I'm thinking or the purpose of this. So this first competition, I just want to start it just so I can get it started. So as we do more competition, we will obviously get better. The algorithm will get better. The build will get better. It's just that for this first one, if we can just get a few cars running, I'm happy. No complaint, no nothing. So yeah, so that's the goal. Just keep that in mind. No pressure, no nothing. Or you just move along and see how it goes. All right. Any other questions? Okay. So who here was able to download ROS, the virtual machine, and then ROS on their laptop? Raise your hand. Oh man, that is not good. Okay, who has not done it yet? You don't have ROS on your laptop. Oh, what did you do to it, man?
It just died.
That is insane. Oh man, this is not good. Okay. Okay. Did you guys not know about the prerequisite, or you just something happened?
Virtual machine was on.
The virtual machine wasn't working for you?
Yeah, it wasn't working for me either.
Oh man. What else? Oh, okay. Who did not know about the prerequisite? Raise your hand. Okay. Yeah.
how the ROS on the brand, it's like it's a simulation on the process that they use that stuff.
If you can, if it lets you, go ahead. I just don't know. I've never tried it before. So, if you have not, what is it? No, I was just gonna. You can ask a question. Yeah.
Does ROS work on Mac? Because I know there's Eagle
You said does Ross what?
Does ROS work on Mac?
So the thing you would need to do first is not just download ROS 2 straight up. You would first start by download a virtual machine. The one that I recommend is VMware. I mean, I never had any issues with it before. So once you download VMware, you download a Linux distro based on your computer architecture. So you download the right one, and it has to be on Ubuntu 22.04. That's the one we'll pretty much use here. And then once you have Linux running on that virtual machine, you download ROS 2, which is what we'll use here. So I would not recommend downloading ROS 2 directly on your bare machine because it might not work well. So
Is this all you need to use it?
No.
Like, I mean, IDE itself.
Well, it's not ROS is not an IDE, so it's I'm not too sure what this is. So if you did not have a chance to look at the prerequisite, if you want, go on your laptop right now, and as we're going through the slide, you can try to like do it. If I remember correctly, the link was tinyurl.com/AIracer.workshops. So for all of the workshops, this is your one stop. Basically, if some workshop require you to have like a prerequisite, it will be listed there. And for this workshop, the prerequisite was to install the VMware with Ubuntu 22.04. How to do it is listed there. Just as we are going through this workshop, if you haven't done it already, go through that and try to install it. It will take a while, so that's why I kind of like wanted you guys to do it before. And then once you have VMware and Ubuntu, you download ROS 2 Humble on Ubuntu. And this is the steps for it. And yeah, so you have other resources like this is the link for if you want to compete. This is the Discord link. This is some slides about the competition, and this is actually a bit important. So this is the competition master document. This has all of the information that I have so far about the competition, all of the rules that we have created. So during your free time, you feel free to like take a look at it. And this is a calendar. Get out. Yeah, this calendar has all of the workshops that are already planned, but more will be added later on as we go through this. So before I continue with the actual ROS 2 workshop, do you guys have any questions, quick questions or concern? Yep. After we what? So this workshop is not to install ROS2. You should kind of like have already gone through it. This workshop is just more to like show you like what ROS2 is and how to actually use it. So yeah.
Sure why this is not.
All right. All right, so let's do like a quick overview of ROS itself. So before ROS stands for Robot Operating System. It is not actually an operating system. It's more of a framework. They just called it that. And before ROS, it was a bit hard to easily manage robotic systems overall. So there was a lack of code reusability. So every time you would have to, code something or like a program or an autonomous systems, you would have to get deep into every aspect of it, from trying to like write device drivers to creating communication protocols and all that. So with ROS, it makes things easier, where a lot of sensors, a lot of like components, they are pretty much plug and play with ROS. So if they are compatible with ROS, you just plug them in and you should be able to easily access them using the ROS framework itself. So with ROS, you don't have to reinvent the wheel. You can just start, programming or start doing your thing with whatever you want. So ROS is not the only framework that exists for that purpose. There's Orca, YARP, PyRobot. All of these are pretty much the same, well, not the same thing, but they have similar purposes. And so what is ROS2 overall? So it is a flexible framework for writing robots. So robot tools, it is built on, the main idea is about nodes. I'll get to that later. And ROS2 is built on top of ROS1, which is a bit older. And with ROS2, there is a improvement on speed and support and flexibility. So about ROS, the whole idea behind ROS is that everything is peer-to-peer. What I mean by that is that each component of ROS, which often called nodes, they act as a single unit that just interact with other single unit. So it would just be a node. You can think of it as like a singular person, that just like interacts with another node, another person, and then overall, all of the nodes together will be able to form the entire robotic system. With ROS2, you can use multiple language for it. Python is the most common one. C++ is the second one. But you could potentially use any other language that has a client library for it. So these are some examples of ones that already have client library for them. And the thing about ROS is that it is free and open source, and a lot of people have like done a lot of things with it. So I mentioned Node already. So the node is the fundamental unit for like ROS. You know, all it does is like giving a certain information from sensors. It does calculation, it does what it needs to do, and send the output result to something else. So if you can really think of Node as being an individual person, right? And the next thing that the next key thing that you might want to know what it is and be familiar with, it's topics. So topics are pretty much named buses. So you can think of a topic as being like an announcement channel on Discord. You as a person, you get information from the channels from Discord, and you do whatever you want with that information, right? So the same way you, a node, get information from a channel on Discord, the same way you could also potentially send information through that channel as well. So think of topics are as channels on Discord. It's just named buses. Ways for our nodes to communicate. And a message in ROS is the data structure sent over the topic. In our case, it would be like, if we are using the Discord example, it would be the type of a message that is sent through the channel. The same way you can send just text messages or like images or videos and all that. So those would be the type of message that you can send. The same way there's like a different types of messages that you can send over topics and that nodes use to communicate with each other. Services, you will hear some people talk about services in ROS. A lot of, if you are familiar with computer science things, a service is in a way like an API. So you just kind of like send a request, you get a result right away. Another way you could think of it is, let's say you are interacting with a bot on Discord. You just send the bot command and you get a response right away. So that's pretty much what services are in ROS. And an action is, in a way, kind of like a service. However, it is not quick. It is a longer process. So let's say if you have a robot arm and you want the robot arm to move the hand from here to here, you send the command for it to like move there. However, as it is moving there, it's not like instantaneous. So as it is moving there, it gives you feedback of where it is currently. And with that feedback, you can even like do things like cancel the request or like change the request and all that. So that's what actions are in ROS. And when it comes to launch files in ROS are pretty much in a way a script. So because everything is node based, so if you have an entire robotic system, you would have a bunch of nodes. And with ROS, if you didn't have a launch file, you would have to start the nodes individually one by one, which would pretty much take a long time. So with a launch file, you can easily just write a launch file that start all of them at once, and that would save you a lot of time. So with packages are what houses your entire system, if you will. So packages have a bunch of nodes that you created for a specific purpose, and inside the package you can easily share it with others. You can easily modify it or download a package and modify it and do whatever you would want to it. Just think of it as what's housing the nodes. And the workspace is, like it sounds like, it's pretty much the workspace for your project. And in a workspace, in a workspace folder, you would have your source folder that has all of the source code for your packages. You can have multiple packages inside of a workspace. And the installed would be what the compiled binaries of it. and all of these, the log and build, are other things that your system uses as well. But the workspace, you can think of the workspace as the system itself. Inside that workspace, everything that is needed for an autonomous system to run will be inside that workspace for it to run, and that could include multiple packages and all of that. So, does anyone have any questions so far? Yeah. You say what? Yeah. VMware, So that would be ROS 2. So if you don't have the instructions to it, just go here, tiny URL. Just go there, and it has the information on how to install them. ROS 2. Oh, you can install. Oh, yeah, because it's. No, if you can download the first one, because ROS 2 you install it on VMware. So if you have VMware, then you can install. Yeah, you install it on VMware. Yeah, what's your question?
For the workspace, are you going to provide generated files for the build and the install, or are you creating?
So those one will be auto-generated. You just get, once you have your source file, you the command is like Culkin build, and then it's auto generates those. Yep. Mm-hmm.
So say package A and B, what would you say their different, like package B holds like robot A, package B holds robot, holds this, package A holds this other robot.
Right.
And then the service will be giving us information to A and B.
You said the service?
The service is in what's the time?
Yeah. So let's say. So you had a question, right, about it, and I think that's fine.
A contains nodes, libraries, and other resources.
Right.
So that means it's its own thing.
Right. Yeah.
Same falls for B. So does that mean that they're technically the ones that are doing systems that are robots?
Yeah, I mean there could be. So let's say let's say package A has a bunch of nodes that is for RESPAR 1 or something like that. And package B has a bunch of nodes that's like for RESPAR 2. And then you can even have like a package C that is a simulation platform. So all of those packages and all of those nodes, you can kind of like start them all together, and all of them can communicate with each other through services, topics, and things of that nature to do whatever you had pretty much wanted to do with them. I don't know if that makes sense.
No, it does.
Okay. Any other questions? All right, and I pretty much already went over workspaces. The source folder will have all of the packages, and in summary, ROS 2 is just a open source robotic framework that allows you to have an easier time interfacing different sensors, and easily, or have an easier time to program robots. And it is peer-to-peer, it is node-based. That means each node, in a way, is like their own individual person, and they just interact with one another, and the way they interact is what creates the entire robotic system. Okay. So let me see if I can, if you have, your laptop and, you have ROS installed, we can go through these real quick. So if you do have your, go ahead. Yeah, I'll post the PowerPoint, and I'll try to this is supposed to be recording. I hope it's recording. I'll also try to post the video as well. So if you go on the one-stop workshop page, there is a live Canva that you can click on that link. And as I am typing on it, you should be able to see things in there and easily copy and paste things that I'm typing. And if you haven't signed in yet, feel free to do so if you just came in. So once you installed VMware and Linux and Ubuntu and then ROS, this is kind of like how Ubuntu looks like. Does anyone already have this set up? Raise your hand if you already have this set up. Okay. All right, that's good. It's a bit small. How do I make it bigger? All right. Are you guys able to see this on your kind of like a live Canva? It might help you out when it comes to like copying and pasting. So whatever I'm going through, I'll try to like write it on here, and make sure you use that preview only, so you have easier space and all that. All right. Okay, so we'll start with the live demo for right now. Once you have it installed, to source it, source is pretty much when you want to activate ROS2 on your terminal. So you use that command. I'm assuming everyone is using Humble, so it's already written in the live Canva. Feel free to just copy and paste. Set up that bash. Once you do that, once you run that, you should get like all of that. So is anyone getting something different from that? So once you source it, if you do ROS2, you should get something like this. If you don't get that, it means that either like you didn't source it properly or the installation wasn't done right. Everyone got it? Raise your hand if you got this part. If you had, okay. Pretty simple stuff. And to create a workspace, you can just make a directory. Let me see. And you can do, so to build the workspace, you would use that command, and then you source the workspace with that. Let me see if I can just get a publisher to run. ROS2 runs simple. Wait, is it simple? Okay, so this is an example of a simple node that talks and publishing hello world and then does a count of something. And you can use another terminal to just run another node, ROS2, run demo nodes, And as you can see, this node, which is it's called the listener, it is basically listening what the talker is saying, and then output it back. So this is just a simple demonstration of how the nodes work. And let me show you topics. When it comes to topics, you can see the topics, and the chatter is the topic that both nodes are using to talk to each other. And you can see what exactly is going on inside that topic right there using this command. So this is just to see what exactly is going on inside of a topic. So this is just a simple demo on how to see what a node is and what a topic is. But now we'll try to see if we can. So far, everyone is good, right? Okay, so we will create our own simple publisher node and simple subscriber node. All right, make do workshop. That is just me creating a folder called workshop so I can separate these from my personal stuff. And once you have a source folder, it's probably easier if I just show it to you here. Once you have a source folder inside that workshop, and you are inside that workshop in the terminal, you can do calc and build, and it creates the installed and log folder. But since there is nothing inside the source folder, this is fine. Nothing will be in those as well. But if you had like besides that, but if you had like an actual thing inside the source folder, it will show something. So let's start with the process of creating our own node, which is a publisher and a subscriber. All right. To create a package with our nodes in it, you will navigate to the source folder. And run this command to create a Python package. It's called my Python package. And what that command does is that it creates a package called my Python package, and it requires the build type I'm emit Python and the dependencies RCLPy and standard messages. These are to just being able to send simple messages in your nodes. And if you look at the the live Canva, you should be able to follow along as well. Let me see. And inside your environment, feel free to install VS Code because it can help with actually writing the code for the nodes itself. So this is the Python package. And don't worry, all of the steps, I will also put them in a document. And even if you don't have your machine right now with you, it's pretty straightforward with the steps on how to actually do this workshops and exercise with the nodes and stuff. You would easily be able to just follow along. But let's see. And I'll just copy this code for the publisher. Let me see if I can zoom in on this. To go through what this code does pretty much. So this is, when it imports the necessary libraries for the node to run. Here it initialized the node and called it simple publisher. This is creating a publisher node that publishes in the ROS2 intro topic. And what it publishes is pretty much strings. And it pretty much publishes this every second. This is what this is doing. And the way it publishes the message is it outputs hello ROS2 and then a count. And after each message, it increments the count. And then like that, you will see hello ROS2 1, hello ROS2 2, 3, 4, etc. And obviously you can change this to be whatever you would want it to be. In my case, let me put that. I'm trying to figure out how to do that inside this. Control plus. There we go. Thank you. Let me see. Yep. If I use WSL for VS Code, uh, where? VMware? Maybe, because yeah, I didn't have to use a WSL extension for VS Code. Okay. And let me get the next step for this would be the subscriber node. Let me put it in the let me put the instructions in the live Canva. It should pop up. Alright, for the subscriber node, I already put the code there. Feel free to just copy and paste if you need. And all of those comments is just to pretty much explain what everything is doing. I'll go through them real quick. It starts just like the other one. You know, you start by naming the subscriber itself. You create a subscription to the ROS2 intro topic. And whenever something gets published to it, it calls listener callback function. And what it does is that it outputs whatever message was published in it, which is pretty much just like the demo. No, I'm just modifying this. I'm just customizing this. You don't have to customize like this. It's up to you. And over here, the main function, what it does is that it creates an instance of the node and it spins it, as in like it runs it indefinitely. It's kind of like in a loop until you press Control C. That stops it and destroys the node. But let's see. So once you have your publisher and subscriber node ready, what you would need to do for them to be able to, for you to be able to run them through the commands, you have to add those scripts to your setup file. So the setup file is right there. Let me just add that. Make sure the indentation is right. And after that, Let me put the next steps there. All right. After that, you just build the workspace. You need to go to build it. You need to go back to the parent folder, the workspace folder itself. Call can build. And once you build it, you now should be able to source it and then run it. So what source means is that you pretty much making sure that when you call the node, it actually understand what to reference to. You source the installed folder. ROS to run. What was it? I think it was called my Python package. And the first node, it was called simple publisher. So as you can see, it's saying that it's publishing Israel said hello 1 2 3. And then for this one, when you open a new terminal, you do need to source everything that is needed to be sourced. Let's go to the workspace. I had already sourced ROS2 Humble. Now I just need to source the setup file. And let's run simple subscriber node. And yeah, so currently it is receiving the message. So this is kind of like just kind of like a quick intro to ROS itself and how to publish and subscribe to something. Has anyone gotten that far? You got there? Anyone else? Is anyone having issue with it? Oh, how did I modify the setup file? So basically, when you write your node, right? So when you write your node, you call it something. For my file that has the publisher node, I called it simple publisher. So once you do that, when you build your package, ROS look at your setup file and be like, and it's like, okay, so this is what you called a node. This is where that node is currently at, the location of the file for it. Yeah, to make the connection so that when you run it with ROS, it knows where to get the file and run the node. Yeah. Does anyone have any questions so far? All good? All right, so let me just put the rest of the document there. All right, what I'll do, I'll just put the rest of the instructions for the workshop here, since it is kind of a lot in a way. We won't be able to go through all of it. And on my hand, I guess the last thing I will pretty much show you guys is I'll show you an example of an actual system, which is the simulation itself. So with this command, I will launch the launch file for the simulation that we'll be using. I will talk more about it next workshop and how to actually get it to work and implement something using that. Let me see. So this is just a simple simulation, and when the simulation is running, you can kind of tell all of the topics that got created from the launch file. You have map, you have drive, all of that. You can inspect them as well. ROS 2, topic, echo. Let's say if you wanna echo, let me see, what do I wanna echo? Let's echo drive, I guess. Currently, since the vehicle is not moving, nothing is being published there. But let me activate a node that will allow me to use my keyboard to move the vehicle. ROS 2, run, tele, up to his keyboard. So as you can see, I'm able to move the vehicle with the keyboard now. I mean, it's a little slow because I set the speed to 0.5 meters per second. I can make it go faster with Q. Oh, no. Let me see. But yeah, this is just a quick demo of like what you can do with that. And next workshop, I will talk more on how to use this simulation and implement something like called automatic emergency braking to this. So what you can do now is just when you get home, when you have some free time, just follow through the rest of this. It pretty much teaches you how to use tools to inspect nodes and all of that, and how to create a custom message type. And what else was on this? And how to create a launch file. And I'll add a little more like practice. So if you want to do it as well, it's kind of like not really an assignment, but more like a challenge to get you more familiar with it. So for the challenge or practice, if you want to call it that, you'll try to like create a multi-node communication system, and the goal is to create a node that publishes like random stuff, random data, and then create another node that processes that data in a way that it gets that data, do some random things with it, like maybe like multiply it by 10 or whatever if you're using numbers, and then another node that kind of like just display that data. It's just if you want to kind of like get your hands on something and try to like practice more, feel free to do that. But as long as you just go through the first part, you should be able to be a bit familiar with ROS and will be a bit less confused in the next workshops. So that's pretty much it for this workshop. I don't know if you guys have any questions, comments, or concern. I will post these in the Discord, and also make like some announcement as well. But yeah, do you guys have any questions, comments, or concerns? Uh-huh. So this file itself, yeah, things you can do for this workshop, as in not like prerequisites for the next workshop, just for you to like practice and actually be familiar with ROS. Uh-huh. Mm-hmm. Source. Yeah. So whenever you open a new terminal, you have to source them. There's a shortcut to like. Yeah, there is one. So the way you could do it is basically. So there's this file called I believe it's called it's called a bash RC. So whenever you open a new terminal, everything in that file gets run automatically. So as you can see right there, I had already added for them to like source ROS, which is humble, right, and source the installation folder for my simulation, and then other nodes that I have. So as long as you add that to whatever you want to source, add it here, and whenever you open a new terminal, it will do it. And make sure you use all of the path, the entire path thing, absolute path, and then save it. But yeah, any other questions? The file. So whenever you're on your terminal, nano is like a command to like open and edit a file. So the file is called you have to be at your home space. To get to the home space, you just press CD, and then nano to open that file. The file is named .bash RC, and then just add that line of code at the end. Just add this source, because this one is for the simulation. You don't have the simulation yet, so it wouldn't work. So you can just add this source to it. Yeah, you could also use the file thing. Browse. Jeez. So yeah, it's this file, and then you can simply add it here. Yep. So you source Humble, and then you source the install folder as well, or no? Because you kind of have to source that one as well. Let me see. Is the first one working?
First command.
The first one is working. So the second one, go to the folder that you have this. If you just follow to this, and then source, install. See that? No, you don't have to.
I think it's better to
And then, well, you can, find.
Well, what I did to do this was I put my, I was able to add the files in the lines code, and I here, this, this way.
Let me see the setup. So let me put on the feedback form. Next workshop, I'll try to make it more organized. Uh huh.
I just delete the file from file export.
Huh?
I just delete the original file from file export.
Yeah, you can. Where is this? But yeah, feel free to fill out this feedback form to it's anonymous, so just so I can kind of like improve on the workshops, deliverable, and things like that, and so they can be better overall. But yeah, that's pretty much it for this workshop. So if you're done, feel free to leave. Really thing.
The stuff you put on GitHub for the title register, I pretty much like got I got to this point, and then that's when I started having trouble. So I was working on that before. So from that, do I pretty much have everything you're showing?
Say that again.
So like I got to this point before I started the workshop.
Okay.
I have this simulation.
And it just doesn't work, right? It doesn't.
Yeah, it showed me like
Oh.
I had this stuff, and I was just wondering, I don't know how to work it or anything. It had the track. I like just click reset or all that.
Try to start.